Okay, guys. Okay, give me a good example, hydraulics element that you have in your car and you use frequently.
Brakes.
Okay, the brakes is perfect. Later we are going to talk about the brake system because that fluid is special. Okay. Other element is the jack. You remember? The bottle. It's nice, no? Because pay attention. It's too much the force that you need to apply here? No, it's a little, no? And you lift 2 tons, 3 tons, 5 tons. With this, you apply 2 pounds, 3 pounds of force here, and you lift 2 tons. This is possible? Yes, the bottle is a good example. You know how much you multiply the force? A lot, no? You lift a car, a truck, with a regular bottle. With your hand. You apply 10 pounds here and you lift the car. Wow, no? That's incredible. I am going to do the schematic of the jack, the hydraulic jack, and we are going to analyze what happened at the input and what happened at the output. That's okay, guys? All right. This is the hydraulic jack. I am going to divide it into containers. And I am going to create 2 pistons. One small piston. In this small piston, we are going to apply a force of 1 pound. 1 pound. And here is the fluid. Here is the fluid. And I am going to calculate with 1 pound applied here how much force I produce in the other side. Pay attention. When I press that piston down, what happened with this piston? Goes up because the fluid, no? If I move this piston here, this piston move it over there. Yeah, to compensate. Suppose that the area of this one is 1 square inch. And the area of this is 10 square inches. It's 10 times the area of this in comparison with this, 10 times. And now we are going to calculate the force over there. And we are going to use the principle of the hydraulics. In hydraulics, if the system is completely closed, there are two factors that stay constant. One is
The pressure.
the pressure. Pressure in point number 1 should be equal to the pressure in number 2. What other factor stay constant? The work. The work. Work 1 is equal to work 2. The pressure and the work is constant. Okay. What is the formula for pressure? Is force divided by area. Yes or not? Papi, follow me. We are going to solve that equation. Pressure number 1 is equal to pressure number 2 because the system is completely hermetic, completely closed. Good? Alright. Pressure number 1 is force divided by area. Pressure number 2 is force divided by area. I know the force number 1. Yes, it's 10 pounds. I know the area number 1, 1 square inch. I know the force number 2? No, this is the question. And how much is the area number 2? 10 square inches. Okay, I want to know what is the force number 2. Force number 1 is 1 pound.
Okay.
Area number 1 is 1 square inch. Area number 2 is 10. Okay, 1 pound and 10 square inches and divided by
1 square inch.
1 square inch. A square inch with a square inch. And the force number 2 is 10 pounds. All right, perfect. Okay, look at this. I apply 1 pound in a cylinder of 1 square inch and I produce a force of 10 pounds. I multiply times 10 in this example. Wow, it is a lot, no? With 1 pound here, I lift 10. It's incredible, no? Okay. Wow. And let me calculate the distance. Suppose that I move it this piston 10 inches. I want to know how much is the movement of this, the distance number 2. What is the formula for a work? Is force times distance. Force number 1 times the distance number 1 equal to force number 2 times the distance number 2. Okay, how much is the force number 1? 1 pound. And the distance number 1? 10 inches. How much is the force number 2? 10 pounds. Times the distance number 2. The distance number 2 is equal to 1 pound times 10 inches divided by 10 pounds, pound with pound, and is 10 divided by 10? 1 inch. 1 inch. Ah, okay, I moved this piston 10 inches and this one only moved 1. Yes, you remember in your hydraulic jack, you move your hand like this and the car moved a little. It's exactly the hydraulic jack. Okay, move it a little, but you move it 1 ton. You understand? Okay, nice. This is the principle of Monsieur Pascal. Okay, with the work, with the work, I calculate the distance, and with the pressure, I calculate the force.